Welcome to the CAD Office Training Guide series for FDOTConnect. I'm Heather Purin, Structural Engineer at WSP USA. Today I'll be going through the OpenBridge Modeler Training Volume 1, Introduction to Model-Centric Design. In this series of videos, we'll take you step by step through each exercise from the guide. In this session, we'll go through some background information and then complete exercise 7.1, which includes generating quantity, elevation, and input reports. We'll also touch on a few other various additional report tools. Let's begin. Before we get started on exercise 7.1, we wanted to go through a little bit of background information. First, we want to talk about the purpose of the reports that we're generating. The idea is to take advantage of the model-centric bridge workflow to help us generate some of the FDOT required deliverables or to produce information that can be used as aids during the QC process. For example, you can use reports to help generate project quantities or finished grade elevations. We're going to talk about some of the limitations as well. As with any program, the quality of the output is highly dependent on the accuracy of the input and also understanding the program limitations. As a designer, you're responsible for verifying the accuracy and the limitations of any reports generated by the program. Specifically, on the material quantity reports, make sure that you have properly assigned the feature definitions and that you use the correct templates and material types when creating a model. This will help you create a more accurate quantity report. There are some assumptions that are made in the materials quantity report that you should be aware of. For example, it assumes that the haunch buildup is linear between the two bearings, so it does not take into account variations from the parabolic beam camber. In terms of the quantity reporting, this would give you an overestimate of a concrete quantity, which ends up being conservative, and that would be the case for all of the FDOT buildup cases, except for case number 4 that you see on your screen there highlighted, where the minimum buildup is controlled at the begin or end of the beam. This is something that the designer should just be aware of when generating the reports. Also keep in mind that anything not modeled, such as a thickened end slab, will not be included in the reports, so you'll have to account for that separately. The cost component in the materials quantity report is from Chapter 9 of the FDOT Structures Design Guidelines, which is the BDR cost estimating chapter. This price information can be edited as needed if you have project-specific data. So that highlighted column on your screen is the unit price, and those come from the BDR, but you can edit them if you have more project-specific information. When using the materials quantity report, you should also keep in mind any unique geometry that did not have a completely accurate template used or may have required workarounds, such as a squared off acute end bent corners. For example, if you model them with sharp edges rather than squared off, that is how it'll be reported in the quantities. Also keep in mind that any elements created using solids modeling rather than the OBM templates will not be shown in the automatically generated quantity reports. You can take a look at Chapter 7 of the training guide for a list of situations where the user would have to supplement and make sure that they verify the quantity reports. Another current limitation to keep in mind is that similarly to the quantity report, the beam report tool, which provides length, grade, beam, bearing direction, rotation, and other information, takes into account the cross slope of the bridge and also the super elevation, but it does not take into account camber, even if it is manually entered in the camber report tool. So you'll have to keep that in mind when taking a look at the haunch thickness or the haunch elevations generated by the beam report tool. Another thing to keep in mind is that for the bearing seat elevation report tool, which provides the pedestal or grout pad and bevel plate elevations, does assume a level pedestal So for beam grades between 0.5 and 2% for FDOT, where the beam seats are to be sloped, that would have to be accounted for outside of the program. All of these various report tools, in addition to the three main ones, will be touched on at the end of the exercise. And then one more thing that I wanted to mention is that Bentley is constantly releasing new versions of OpenBridge Modeler with program updates. They generally do that a couple times a year. They incorporate bug fixes and enhancements, including introducing additional features. They're usually pretty good about user input, and they try to incorporate user-reported bugs into upcoming releases. They also do keep a log with each release that details what has changed since the previous release, which you can find on their website under the Bentley's community site. I generally just Google OpenBridge Modeler new release, and one of the first entries is generally the what's new in OBM page, and it'll have the latest changes with all the details. Some of the limitations mentioned in the videos have been communicated to Bentley, so some of them will likely be addressed in later versions of the program than were used in this series of introductory training videos. So just keep that in mind while you're watching some of the exercises. Let's get started on exercise 7.1. The first part of exercise 7.1 is to go ahead and open up our 7.1 Begin DGN. Since we're already within our data set, we can go to Browse, and then we will navigate to the 7.1 Begin DGN. As with other exercises, we just want to make sure that everyone is on the same page for the start of each exercise. So as we mentioned in a previous video, this is going to be one of the instances where changing the working units is helpful, since we are creating a quantity report and we don't want to report fractions of a cubic yard of concrete in our quantity report. We want to work with decimal feet, similarly to how the FDOT basis of estimate works. So in order to change our working units, we will go to File, we'll go down to Settings, then within the Settings options, we'll select File, and then we will go to the Design File Settings. Once that's pulled up, within the Working Units category, we'll go ahead and change the format to just master units, and then we'll make sure that our master unit is at survey feet, and we'll change our accuracy from 1/16 of an inch to 3 decimal places. All right, now that we've got that set, we can go back to our model. And we're going to go ahead and just verify that our active model is our main bridge. Since we modeled the approach slabs as bridges as well, we just want to double check that our bridge itself, rather than the approach slabs, are the active bridge model, which it is because it's got the symbol here. And for the quantity report, the reason that we're doing this is because the only options are to generate the reports for either the active bridge or all of the bridges in the model. You can't isolate one of the bridges unless it's active. In our case, we're going to generate the quantities for all 3 of our bridges, the 2 approach slabs and the main bridge, but we're going to set the main one as active just in case we want to display only that bridge. So we're going to open up the Materials Quantity Report Preview area by going to the Analysis and Reporting tab, and within the Bridge Reporting group, we will select the Quantities Report tool. So what that's going to do is open up a preview area for the quantities report that we are looking to create. And as we mentioned, you can either do the active bridge or all the bridges. We'll go ahead and set everything to all in terms of the bridge and the unit. and then we will hit submit to go ahead and generate our quantities report. And once it generates, we'll have a few pages here. It looks like 7 pages of quantity report. And we've got this in our preview pane right now, but we can export it. There are a few different file formats that you can use: PDF, Excel. We're going to export it as a PDF. And you could change some of these settings, but we're just going to keep them all at the default. We'll select OK. And then we've got our Explorer box. It's going to pop up and ask us what we want to call our PDF. We're going to go ahead and save it within the structures folder and the engineering data folder. And we'll just call this quantities report bridge 2. We'll save the PDF. And it will ask you if you want to open the file. If you say yes, it'll open it up in whatever your default PDF viewer is. In our case, it's Adobe Reader. And as we mentioned, it's also saved in the engineering data folder within the project folder on in the WorkSets FDOT dropdown. So you can also access it after the fact within that folder. So we've got our materials quantity report here. As you can see, it is broken apart into superstructure and substructure quantities. As we mentioned before, the feature definitions and the assigned material properties are what is used to determine the component type, material name, and material type. And as we also discussed in the background section, you'll have to make sure that you understand both the program and the user assumptions regarding quantities, and they should always be verified by the user. Again, feel free to take a look at Chapter 7 in the training guide for additional information. Also mentioned in the background information, we've got the unit prices here that are associated with each of the material names, and those are from the BDR cost estimate section in the SDGs. But you can't update the unit price associated with a given material name if needed. And it does give a total cost breakdown by superstructure and substructure, as well as a grand total cost. It's got some graphs breaking down the proportion of the total bridge cost, and a few other quantities. This is for the approach slabs, so it'll be the same thing for both of the approach slabs as well. And again, remember that anything that is not modeled, of course, will not be included in the quantity report or in the cost estimates. So real quick, we can take a look at the unit price, editing that within OpenBridge Modeler to our model. And you can open up the materials library using the materials tab here under utilities. So we've got our libraries here. You can open up the material library. These materials properties are pulled from the FDOT library, and they can be adjusted as needed for specific projects. You can create new materials if you'd like using the defaults. If you go in and right-click on one of the entries, you'll have an option to create a new material from a copy. So if you don't want to modify one of the base entries, but you would like to create a new material, you can do that. You can also pin materials up at the top if you'd like, if they're often used, and you can edit any of the material information in here. Like we said, if this unit price on your project is actually $175, you can go ahead and change it there, and it'll use this unit price in the quantities. So we've got concrete material, steel material, and miscellaneous material. And these are, again, maintained by the material library that FDOT provides, and they will be updated with new releases of the FDOT workspace. So the next part of exercise 7.1 is to generate a deck elevation report. There are various elevation reports that can be automatically generated within OBM, but we are going to start with the deck elevation report, and we'll talk about some of the other ones a little bit later. So we can go ahead and close out our preview pane for the previous portion of the exercise, and we will go back to the Analysis and Reporting tab, and then within Bridge Reporting, we will select the Deck tool. And as you can see at the bottom, it's got a prompt to select the Start Limit line. So we are going to select the support lines associated with the just the bridge. You can also select the support lines for the approach slabs if you wanted to generate elevations for those. But in our case, since in our model, as you can see on the right, we generated the concrete deck elevation rather than the riding surface. There's that difference in the asphalt overlay. So if you generate the deck elevations of the approach slabs, you'll just have to have an adjustment after the fact for that asphalt overlay. So we will go ahead and make sure that we are selecting support line 1, and then for the end, we'll go over to the end of the bridge and we'll select support line 4. And then once you have selected your 2 support lines, you'll just left click to accept. And now you've got your deck elevation report dialog box that comes up, and we'll call this report the Bridge 2 Deck Elevations. And as you can see, our start and end are our support lines that we selected. You can modify those here if you wanted. You could put an offset if you did not want the elevation given at the support lines but wanted them at a different location. In our case, we're going to keep it as support line 1 and 4 because those are the front face of back wall, which is what we want in our elevation report for finished grade elevations. So the transverse lines, or the T lines, will be set to parallel to the start of the support rather than the alignment. So that's correct based on the FDOT requirements. For the report type, rather than the station offset and elevation, we're going to go with the consolidated report. We're going to use that since we don't need the station offset information in the table. Also, the station offset and elevation option doesn't show both the support line and bearing line deck elevations at the same time. So the consolidated report in general is better. For the points per span, we're going to go with 6, which will ensure that we meet the SDM requirement of no more than 10 feet between T lines, since 2 of these 6 points are the start and the end span locations. In terms of the common references, we'll toggle on which longitudinal points we want our deck elevations displayed along. We'll select the alignment, and we'll do an offset of -32 feet because in our model, the alignment that's used is the center line construction, which is this line here. So we want to make sure we tell it -32 or 32 feet left in order to get the correct PGL line. And then we will also click and select the left deck edge and the right deck edge to give us our coping points. And then you'll see that there's a left and right edge for each of the barriers. We're only going to need the gutter line since we've got our coping handled. We don't need the back of the barrier. So we'll hover over this one on the left. This one is barrier 1. So for barrier 1, we want the right edge because that'll be the gutter line. And then when we hover over this one, it'll show that it's barrier. So for barrier, we want left edge to give us a gutter line. And then we'll also select beam path so that we can get points along each of the beams. And we are not going to auxiliary reports to include, so we will just click generate. So now we've got our preview pane, similar to the quantity report that we worked on previously. We can also export the deck elevations into a few different formats here. In this case, we are going to export it to an Excel file. So we'll select Excel SX. And in our export options, the only thing that we're going to change here is that we want to call this the sheet that comes with the Excel file. We're just going to call that deck elevations. We could change it after the fact if we wanted. So we'll select OK, and it'll have us save it. It's set already to the engineering data folder, like our other reports, and then we'll just call this with underscore bridge 2. So we'll save the Excel file, and it'll ask again if we want to open it, and we will select yes, and it should open up in Excel now. So now we've got our report opened up in Excel. So the way that it displays it is not exactly the way that we want, so we can go ahead and modify it. So first we're going to delete column D and column K. So I'm holding down Control and selecting these columns. You'll notice that these are the same, it's duplicate information basically for the start and the end support line. So we don't need those in there. We'll Control, select both of the columns, and then we'll right click and click delete. Another thing that we want to do is add a location. This is the location using the OBM terminology, but we'll go ahead and insert a column here, and we will call it what we want it to be called based on how we report it in the finished grade elevations. So we'll call this PGL, and we'll call this left coping, right coping, right gutter, left gutter, and then the rest of these are center lines of beams. So we'll type center line beam 1, and then we'll drag down and let it autofill. We'll go ahead and just copy and paste this column into spans 2 and 3 just to get some of the formatting a little bit closer. And we will also go ahead and change the column headings to closer reflect what we use in finished grade elevation tables. You can take a look at exercise 7.1 in the manual to get some of these inputs rather than trying to pull them off of the screen right now. You can also modify and unmerge these cells as you'd like, but for now we'll go ahead and just copy these headings, making sure that we update for each of the support lines. So this will be interior bent 3 at the end of span 2. And then we'll copy, paste these for span 3. Span 3, the start is centerline interior bent 3, and then the end is just the end bridge location. So now this file is got pretty much the base information that you need to get started on your finished grade elevation table for the plan sheets. The dates, like I mentioned, in terms of column widths or row heights, however you need to manipulate it. Also, these rows are not in the correct order, so we can move these around in order to get it the way that we need it to be formatted for the finished grade table. And then after it is formatted, You can then import it using your import method of choice, either the FDOT Link Data Manager tool, the OBM Place Table tool, or a third-party add-on if you'd like. So now we've got a good starting point for our finished grade elevation table. The last part of exercise 7.1 involves creating an input echo report. This report can be a pretty helpful aid during the QC process and should be used alongside the OBM bridge model itself to verify the model both numerically and visually. You can control how detailed you want the report to be within the preview area, and we'll go through that once we get to that step. You can close out all of the other preview panes or boxes that you've got open from the previous portions of the exercise. And we will go to the Analysis and Reporting tab, and then click Input Report. And then the preview pane will pop up. In our case, we're going to stick with the active bridge and the active unit. For the report options, we're going to select all. Like I said, you can control which ones you want to be displayed depending on if you've got the QC broken up into different sections maybe. So we'll click OK, and then we'll hit Submit. And that'll generate our report. We've now got our report here, which for our bridge is 31 pages. So as you can imagine, the report could get pretty long if you've got longer bridges, so just keep that in mind when you're generating the output. So we can also export it like we were before. So we'll export this as a PDF file, and we will keep all of the export options as a default. We'll select OK. And then we will save this. We'll add to the end of the file name, Bridge 2. And we'll save it in the engineering data folder. Once it saves, it'll ask if we want to open the file, and again, we'll click yes, so that it opens up in our PDF viewer. And now got our PDF report, including the bookmarks. So just to kind of scroll through real quick, we've got the deck input report here with all the variable constraints that we input. It's got the version number of the program on the bottom left, so that whoever's checking it knows what version they're using. It'll have all the beam layout, input, report, number of beams, and all of the input that was used when generating the beam lines. And again, this will have to be used with the model itself so that you can see both visually and numerically that everything matches up the way that it should. The last thing that we're going to cover in this video are some of the other tools that are available in the Analysis and Reporting tab. The first one that we're going to take a look at real quick is the Beam Report tool. So this gives you the actual and projected lengths, the grade, bearing, direction, rotation, as well as some beam elevations and haunch thickness and haunch elevations. You can tell it however many points you want. We put 11 so that we get 10th points. And then when you hit submit, it would regenerate this report. As you can see, it's got the beam lengths, grade, direction, rotation, and lower down, it's got some elevations as well as haunch thicknesses and elevations. Now, as we discussed in the background section, the haunch thickness and elevation sections of the Beam Report tool are not very helpful in their current form, since they only take into account the vertical curve and the cross slope or super elevation, but they do not take into account the beam camber. They basically assume a straight line from bearing to bearing. So you would have to calculate the camber effects separately. The limitation is pending enhancement from Bentley for pre-stressed girders, so it will likely be updated in a future release, but just keep that in mind if you choose to use this Beam Report tool. Next one that we're going to look at real quick is the Bearing Seat Elevation Report tool. Now this provides the bearing seat or grout pad and bevel plate elevations and thicknesses along with a diagram at the end here. So again, as mentioned in the background, they do assume a level pedestal. So make sure that if that is not the case for your beam seats, you shouldn't use the report as is. Again, it would have to be modified. But again, it reports it at the ahead and back station, or the ahead and back location for each span. And then we've got the beam camber tool that we can use, and it allows the user to input the camber and self-deflection in order to be used in the beam camber report. As we will put in some numbers here, and then we will generate the report. So we'll say that the camber is 1.063 inches and that the dead load deflection is 0.375. And then you could either save the information or you can go ahead and generate the camber report. So we'll just use the defaults, but you can toggle on the span and beams and points as you'd like. And this will show you basically some construction elevations, such as the screed elevations and the top of beam elevations here. So you've got all of this input here based on the camber information that was input. So this does include the parabolic shape of the camber, but it's only used within this reporting tool itself. The program will not use the camber values entered to generate this report in the other tools. And then the last report we're going to touch on is the pier elevation report tool. And again, we'll just use this as is to take a look at it. And this reports the top of cap elevations at either end and the top and bottom of column elevations if you have columns, and then the pile cutoff and pile tip elevations, obviously based on the information that you've input in terms of the pile lengths. So those are a few of the additional reporting tools, and they could also be exported similarly to the quantity, deck elevation, and echo reports, and they can be used as supplementary information as long as you understand the assumptions and the limitations. Thank you for joining me today for the CAD Office series for FDOTConnect. This was Exercise 7.1, Generating Quantity, Elevation, and Input Reports for the OBM Intro to Model-Centric Design Guide. This is the last video in the introductory series of FDOTConnect OpenBridge Modeler training videos. Be on the lookout for future additional advanced topics by FDOT.